Hello, Earth. This is welcome to episode 32 of season 3 of Making Cell, a series of videos where I record myself designing and implementing a programming environment called Cell. If you're just tuning in for the first time, I recommend you go check out github.com/autocodenl/cell. So let's just continue where we left off, which is in the midst of rethinking the internals. So we were I was thinking about this by the way on and off yesterday evening after recording and today throughout the day. So that basically we need to be careful with self-reference now that we have calls. Always every call goes inside the data space, and there's actually one call that cannot go in the data space is add, because add brings the entire thing, and you cannot bring the entire thing from the entire thing because you will make the thing reflect itself, and that will never finish. So we're going to go Russell and Whitehead on this and forbid self-reference. Actually, we're not forbid it, just return an error, and this ties back to tracking dependencies in the engine. But so yeah, so it has to be a straight line to cell get, but we were still not there. We were doing we're doing this, if I remember correctly. Yeah, I was trying to understand the execution pattern of things before breaking them. So I have the old definition of cell call, which is great. Well, not great. It's great that I have it, so I can do one thing at a time rather than breaking everything and then taking forever to put it back together. So if I go here, I am in the process of understanding all of these variables because I want to massively simplify this. So the context path is just used for basically getting values from their context. So it could be that, let's just write this down. Yeah. Let's just move this. So we go get the frame of reference. You're getting the value from this, the result from is where the response is, and then the difficult one is the target path. It shouldn't be difficult, but it is, and I think what makes it difficult is that it's in between the context path and the value path, so to speak, right? So yeah. Middle part goes all the way from the left up to the rightmost add, and then also has an equal at the end, right? Yeah, this is where we put the value we obtain. But what is this prefix? Yeah, the prefix is the target path with add and the first item of the value path. Yeah, that's what I need to understand better. I'm obsessed with this album to the point where I cannot even listen to 3-4 songs in a row. I need to go back. Because it's prefix used everywhere, so it will be so you add the rightmost adds and the first element of the value path. Okay. The target path plus the rightmost add and the first step of the value path. What is this? What I could do is this. OCV. Yeah, I don't need that for now. Yeah. What, but I don't understand why I use the prefix so much. I just don't get it. Oh, something else that unrelated but important. Also, an add at the as the last step of a path is a literal, not a call. So it doesn't expand to the whole thing, and it also lets us have literal adds as last steps. Yeah. and yeah, the previous length. Yeah, if the length is less, sure, it's not the same thing. Yeah, so you're comparing. That I get. And here, yeah, this if call, yeah, we're just basically making the prefix grow there, or like going up. But I don't like this code. So you know what we're gonna do? This. So we can just start by doing actually this, right? Interesting parallel here. The target path is what we used to have before. And the value path is what we have now. It's the first time I see this symmetry. Well, probably not the first time, but I really didn't have it in my mind. Interesting symmetry. What I don't get is that is supposed to be on the right and target path on the left. So how could those different places be later compared to see if the value changes? I see. The target path should point to the previous value, and the new, it will be there at equal, and the new value comes from at. So this is how things get updated. It makes sense. Yeah. Yeah. And then you actually do the other stuff here. Setting place. So iterate value path. We iterate value path here. So for example, value path could be, yes, always the stuff to the right. If you have x and y, you would iterate this 2 times. And try x add do with the context path, right? Yeah. Yeah, this is the walking. This is fine actually. I need to illustrate with an example, but it's perfectly okay. I don't understand this. Let me just read this part, which is the part I want to salvage here. And an interesting thing there is that we're just looking for add do somewhere else, but it could be a call to add if, right? And what about another reference? On with finding a call. It's just with an example to illustrate this part. So I'm rewriting logic of resolving calls. 3 calls to resolve. I just wrote this yesterday, but I wanted to write it again today. It's a reference sequence conditional. It could be so you have this, and then somewhere else you have in this case we'll check in this case actually add bar when responding to the reference at foo, we'll first try to get bar hello 1. This will respond with nothing because there is nothing there. So we try to get bar add do. In this case we succeed. We found a call. If instead we had we'd first try add bar hello one, nothing. Then would be bar do, nothing. Then bar hello do. That will work. The message will be 1. The message will be hello 1. Like this is that it could be a reference or a conditional. A reference, however, would be solved, I think, by the jumping over equals that we already do. Where is that? I'm quite tired, so that's why I'm saying everything that I think. Oh, look at that. So we were just not implementing at ifs that were elsewhere. This is another unit of evidence. Yeah, unit of evidence now. Ban in the Turing sense. How much is a ban? Yeah, this one. Yeah, like 10%. Yeah. Let's just be qualitative for a while. I'm too tired to be precise. Well, significant evidence that the approach of cell.respond is flawed and has to be simpler. So now what? Why am I looking for this add do like that? Why am I walking at all? With reference, by walking I mean at bar hello 1, then at bar, then at bar hello, by the way, the last step should be unnecessary because the last step was the first where we just got the whole thing. Right? Yeah. So you should not need to walk. So why is walking necessary? To distinguish within the value path what's the path to the call and what's the message. That's why. The essential part here is the walking. Growing, trying with the growing paths that go from left to right and stop at the whole value path -1, which is the original one we tried. The logic should be that if whatever comes is starts with an at, we bring it. No. No? I'm not sure. Let's say that. Let's try to invalidate that thought. Have bar hello so we have 1 here. Yeah, so then the question is, what is foo equals? If we go with just straight comparison, we'll get nothing. There's no bar hello 1. If we try just bar, we'll get stuff. But this is not our getting, unless what came after bar was at. So we move on to bar hello and we find that it has an at behind it. It points to a straight reference. A reference really is a call without message. Yeah. Did I say this before? In Todis? I honestly don't remember. destination of a call is that which points to a value that contains no calls. No message is necessary, exactly. Okay, calls without message are also considered calls, yeah. Yeah. I defined almost a year ago. Yeah. So it depends on straight reference. So because that reference doesn't take a message, the call cannot really resolve to a value because we'd be ignoring the right part of the value path in bar hello 1. But what if we had this? In this case, it'd be meaningful to resolve this as a call to A with 1 as the message. Not just meaningful, but actually correct. So we can not also just look for bar hello at do. We need to see if that eventually leads to a result that yields a call to add do or add if. What am I doing? This stuff, I'm working on it in the evening. Doesn't make it easier. It shouldn't be that complicated, right? Yeah. How do you deep and find the add do or add if that's the rock bottom of the call, or if it's absence? You can just jump over equals. You jump over equals, and if you find an add do or add if, you have your call, and the place that you, and the split, it's really a split used on the value path determines what's the call and what's the message. So yeah, this will work. So you look for add if for a do at the end of each of the combinations, and when you find something, you have the split. And I'm also suspecting quite a bit of what I implemented in cell.do. Yeah, that function is ugly. It's 85 lines. The errors are fine. So I need to do this jumping through. Okay, before I get in there, yeah. So yeah, I was just thinking, let me take a quick look at this one. Under define, you update the definitions and it just run them. So in the old code, going back to cell.respond, we already detect if we have do here at the beginning of the value path. This is indirect, basically, right? Yeah, that's exactly what we are looking for, an indirect call. That's why at the beginning I almost didn't need this when I didn't have indirect calls, because you just have if, do, and then you get the actual value, and then you're done. Let's rewind a bit. The easy version was just a call to add if, or a call to add do, or a non-call, just plain not, or a reference. Take the whole thing. All good. But if you have indirection, this won't work, you want to define calls that you will use elsewhere. That's where all of this machinery comes in. This is just a definition, not an execution. This is an execution of a conditional. Interesting that a conditional has no definition. Let's go with this one again. So, well, not just direction, but actually calling your definitions. Yeah, I don't like that these are like so outside. I want it to be in a single flow. Although this definition of a conditional is just so simple. So let's just go back to the hairy part. Hairy part, you know, hairy part. Hairy party, I guess it would be something else. So you'll have to excuse me. Where's the part? No immediate if or do. No immediate. No immediate reference. Then walk the. Actually split. Or shift. Walk. The splits on the value path to find something. If that something jumping over equals leads you to an add do or an add if, call. Yeah, that's the hairy part. Wait, why add if? It doesn't make much sense to send a message to add if, right? Add if has its cond. What is it? Cond. Cond else? CD. but with the purpose of having some part of the data space referencing at if and then you passing can't do else. That makes no sense. Just write at if directly. At do is this is an important decision. At this is the only one that makes sense to refer to indirectly because it's actual logic, including ifs inside. The only thing that makes sense to store elsewhere are sequences. Well, references too. Conditional, you just write. So no need to handle at if indirect. Now time, yeah, we're almost done. So in the end, I'm ending up with something very close to what I have, which is emotionally displeasing here. No, why is it displeasing? Because I'm just dealing with the definitions here, not the executions. Well, this I can almost forgive. I don't like this duplication at all between native and non-native. Yeah, the thing is, they're separate paths, really, because how do you add native here in the sequence? If you find nothing, go to try a native call. Native calls we don't even walk, right? Native calls we don't walk because we just use the first step of the. Let me finish this sentence before I start the next one. We don't walk because we just use the first step of the value path to identify native call, and if we need to, we can change it later. I forgot the other thing I was going to say here. Oh yeah, nota bene. Yes, nota bene. I also use the term walking confusingly. In the definition of cell get when the function walks up the context path to find a value at its query path. The mechanisms are related. But the one of cell get works with smaller context paths, whereas the walking in cell.respond works with growing segments of the value path. Okay. Well, almost seem to know what should happen. But what about overwriting do? You could have a reference to do definition of do outside everything at the outermost. We should hit that before we hit the native one. I think that rather than implementing this call, we should go even deeper and really see what do is doing, both in definition and execution, because that's the crux. If we figure out an elegant way to rewrite the paths, not rewrite, to expand the paths, respond to calls, it's all there. We're not far. All right, I'm gonna stop here. Thank you for watching.